Our final sections of the day. We have two speakers for you. Our first speaker is the lead design systems engineer at Bumble. And come here a minute. You see these? The pink laces, the clean, pristine shoes. He has over 60 pair of sneakers, so he can wear, a pair a week for more than a year without repeating. But these he saved for you, because you mean that much to him. Please welcome, to talk about design systems, please welcome Raul.
Thank you. All right, so this is my big head here. I think I'm the only one actually with this slide with my big head. So I'm Raul. I'm lead design system engineer at Bumble. And a couple of cool facts about me is that I'm always working with designers. So like a lot of us don't actually like to work on this bridge, or it goes to Figma files, Sketch, whatever you have, and put some comments or trying to achieve this thing that we call pixel perfect. But I'm the one that is always there. So I'm a very opinionated person that always go on design files and criticize things that I don't think is right, or trying to help them to achieve. But as I will say, like, I have a lot of sneakers. This is just not a lot of them. It's just like the ones that I keep close to my gaming room, which is my office. But I have 6 pairs of sneakers, and it just keeps growing, and growing, and you never know. Like, I think once you start that, you just keep going because you're ashamed of stopping. Right. So what is actually this talking about? Like, we are in a scenario where everything is about AI. We have a couple talks today to talk about AI, how you can actually have your agents doing stuff. You have as well, cloud codecs, all doing stuff for you. But when we come to enterprise level, we have a high pressure for our C-level, let's say, to introduce AI on workflow. What that means? Like, means that somehow we need to learn Cursor, which does not have like proper Xcode debugging, to build our UI. Thank you. So we need to learn like different tools. We need to learn how to integrate everyday AI on workflow, and things change every single day. So this presentation today might be meaningful, but tomorrow, we don't know, we might change it. So what I'm going to show here is how you can actually build better UI using AI and using whatever you have in-house already. So like, I structured this topic, like this presentation, as in small sections, so it's easy to follow because there's a lot of content there. But the first one that I want to go with is the agent UI problem. And beforehand, I have like a couple of screenshots. If you are one of the screenshots, I'm sorry. I'm not criticizing anything, but I just want to prove a point. So how many of you actually end up on Twitter or some websites and someone created a massive, like, I have this AI wrapper and it has the same UI, right? That's what you see. Like, someone just created a new AI tool, like, oh, I can do scrapping for you, which you can do it on ChatGPT. Or I can process your data that you can also do on ChatGPT. Or whatever you decide to do. Even like, I want to rename my layers on Figma. You can do with some plugin or even Figma native, but there's a plugin for that. Majority of these websites are generated by AI, and people just do that without any explanations, just prompt, and that's done. But why this actually is not a good solution? We come to a point that everything just looks the same, but we don't actually know the answer. And the answer is quite simple. Like, agents, they're not very reliable to produce the same quality of code as UI engineer. They just don't work in the same way that we do. Agents or LLMs, they don't actually think. They use pattern matching to detect whatever you want to process information. So if you keep feeding the agent with context, it gets better result. But why is that? Because you need that information so the agent understands. So if you want to do a button, and you just prompt your AI to say, like, hey, make me a button. Depending on the platform you're running, which it could be Android, so you're going to have like mature UI. If you have Swift UI running, you're going to get the full button behavior. But as you start adding more context, like I want a border radius, I want a border, I want to change this font, it becomes much more information where the AI can actually process the information and give you the output that you want to. But it still is not as the same as UI engineer, because as UI engineers, as engineers, we have access to much more rich data that allow us to process fast and deliver things that we believe that are right. So we can detect things without actually having to prompt. So yes, we deliver fast, of course, with AIs, because just put a bunch of words, and then you have it. But being fast actually is being efficient. Does your code actually scales? Like, not really. Like, especially enterprise level, it becomes a little bit more tricky because you have so many layers of architecture that your context becomes bulky, and sometimes you even have hallucinations. But you always get this, when you're trying to argue with the AI, which is, as basically my favorite one, just putting caps, you get this, you're absolutely right. So your UI looks shit, and you're like, please, fix it, change this border, which you probably took like, it would take you a minute or so, but you prompt, because you're already on that path, and you're absolutely right. But what if we could change it or work with the agents so we can actually build UI like your best dev? I'm not promising you that it's going to create something that is amazing. It's not going to create Facebook UI. That's not what you're trying to do. I'm not going to give you the golden path, but I'm going to give you something that you might use and it works. So here is a simple prompt. You don't have to read it at all. I'm just going to resume. So this is a prompt to actually, if you used Bumble before, this is the prompt that would generate the Discovery tab from Bumble. Just prompt a couple card designs and just a couple things. I gave 3 UI agents, like 3 agents actually, the same prompt, and all of those agents has the same image as a reference. So the main goal here is like just with an image and a prompt, what you can produce, what we can get from this. And this is what we get. At first, this is the design of Figma. It's public on an app, so that's not a problem there. So the first thing we get is Figma Make, ChatGPT, and Cloud Code. I'm questioning myself about the ChatGPT, but I'm going to talk about that in a minute. So first one, Figma Make. This is perfect. I'm not going to lie. If you want to build a prototype, something very quick, just with a prompt and an image, that's what Figma got me. My PM want that. So every single, C-level, if they see that, they're like, I'm happy with this. It's something that how we can actually make this more like a prototype so they use it. We can test, user labs. Like, it's perfection at this point. There's a couple things that are different, but you get the whole context there. You get the text, you get the badge, everything is just right. But we jump to ChatGPT. I don't really know what happened there. It's GPT-5, same prompt, same image. Like, I don't really get it. I was much as surprised as everyone, to be fair. And I tried twice, and this was the best result. Maybe it's just my subscription. And Cloud Code, actually, it's very good. I'm not going to lie. If I look at both of them, I could test something with the user. But Figma Make, can we actually test with the user? Not really, because we are iOS engineers, and this is React. That's actually what's the output from Figma Make. And how actually we can test this on our apps, right? So what's the biggest problem here with the UIs? So why does AI struggle? Context. Everything is about context these days. Like, what we give AI, the agents at the end, is just prompts. We're just prompting, refining the prompt, and keeps going, just building context, which is, we are trying to mimic the same context that you have as an engineer, which sometimes is not very reliable because you need more information. You have access to information that they don't have. Constraints, which is very important. Like, when working with UI, we have different constraints. That AI just get a lot of information for some reason, sometimes it's not needed, but if you ask to build a dating app, what happens is, how many dating apps are around there? We have Hinge, we have Tinder, we have Badoo, we have Bumble, we have Grindr, And we can keep going. There's a lot of different patterns, a lot of different apps. So all these actually, it's the information that the agent was training to, and that's why I get processed in the context. And this creates the hallucinations because we actually are just preparing the context. And they need a better reference to refine the output, because just giving something like, yes, the button could be yellow, but without knowing visually how it looks like, and understanding that AI is not in that point that actually can create something from scratch, you don't actually get better results. So when in the prompt, original prompt, we have a carousel, so it creates a carousel. It doesn't know that actually perhaps a carousel needs to, as you change cards, it wants to expand or zoom another one. It doesn't really know. But without all those inputs, it's just guesswork. We just keep working with guesswork, and that's what the AI agent keeps doing all the time. But how we can actually try to change this behavior, because if you look at Figma Make did something great, which was guesswork at that point. We just had the prompt, we have the image, but how we can have something very consistent and reliable, something that we could ship to production, and it's how we can have something that actually is very close to Figma Make, but is native. It's something that actually we can have on our SwiftUI projects or UI kit. It doesn't matter. How we can actually achieve the same behavior with the less structure that they have. A short answer is called design systems. That's confettis. So to make sure that your agent can produce the output that you're expecting, you need design system to be able to process that information. You don't want to always create the button over and over and over again. Your reusability is already embedded in the design system. If you think about the Glass UI that Apple introduced for iOS 26, that's a design system. If we go to Mature UI is a design system. We have TransferWise with a beautiful design system as well. There's a lot of design systems out there, and that's how they manage to build such good products, because instead of having the AI to fill the guesswork, we provide all the components that they need to use. And to achieve everything that we want to, I have the concept that I call the 3 agent enablers, which are pretty simple. So agent enablers are what I call the secret sauce that allows your agent to understand better what you want to perform with less prompting, less guesswork, less writing. One of them is the first one, as I say, is the design system. Design system is the biggest part here. It's all your UI elements that's going to be fitting the context, and the agent can actually produce the output that you're expecting. The second one is a delicate topic, because I know a lot of people don't like MCP, but we need MCP to achieve, because you want to try to achieve something that is, with one prompt, you can get the same output, the right output. And the last one is agent rules, which was not introduced a long time ago, where you can actually tell the agent how things are supposed to work. Technically, if you feed these 3 informations to your agent, you should be able to get very good results, which will reduce the guesswork. So, going deep into these 3 topics. So, design system is pretty much the agent operation system. It's everything that's UI related will be your design system. It's already happening when you're trying to do SwiftUI. It's happening when you're trying to do web nowadays, because they have Tailwind CSS. Android, same thing, repeating material. So design system gives everything that the agent needs, which is structure, your tokens, your components, and all the rules that will help you to reduce ambiguity, which is one of the very important things. So a lot of people probably familiar with what's design system, but if you don't know, crash course. Design system is a set of reusable components with tokens and structure. They give you governance for UI elements, and they let your system understand, okay, can I use this component with this? Can I combine, for instance, a button with a checkbox. Of course not. It probably is a different component. But it gives you this governance, it gives you this structure, all the rules that you need. And when we think about scalable UI and tokens, that's also what the AI needs to understand how to connect the dots together, because consuming components is very easy. It's a simple process. But connecting all of them together in a way that actually makes sense and scales is a little bit more tricky. So going then, tokens. For those who know your tokens will give you the spacing that you need, colors, typography, every primitive element that is needed for your components or for the design system. You don't actually need just to use tokens on your components. You can use out of them, so you can properly connect things together. Then we have components, which is just the semantic primitive meaning of a button could be an action card, could be a card, could be a checkbox, anything that's a component. And then we have the rules, which is what I say, it's the governance, can the components connect to each other, how accessibility works there, what are the constraints. There's a lot of cases that, if you think about it, Apple has the design system, yes and no. Technically, SwiftUI is actually a UI kit because it's there's much more freedom to connect components than actually rules. So you can mix components all together because they don't have a lot of rules. When it comes to design system constraints, it's a little bit different because you can connect some components to others, but not all of the components. It's about the structure at this point. Make sure that your design system represents the brand identity. And feeding this information to your agent is pretty much less guesswork and better output, because instead of have the agent to understand, oh, all right, you want to build a card, and the card has badges. What is a badge, right? What the badge accepts an emoji, accepts a text. It depends of the image that you put. You don't know at that time if it accepts that information, but reducing this guesswork is going to give you much more freedom to experiment and better outputs. But it's all this structure itself is not going to help you. It's going to help you, but not much. You need much more information than that, because agents need the context, which we don't have. We rely on the user for that. We're just giving the structure, and they need the intent. And that's when MCP comes to work. Delicate topic, but MCP, crash course, everyone knows MCP, but allows your AI agents to speak with tools. Unlike using MCP for things like GitHub, Firebase, you should think using MCP reliably. You need to use MCP for tools that actually matters. Like Figma, Sketch does not have one yet, but tools that you can actually they don't have CLI. But you need the context from them to be able to perform your work. So the way it works, more or less, is this. So we have a unified API, and your agent's going to be calling, and it can connect to all those tools. In these three samples, that's Supernova, there's ZeroHide, and there's Figma. For those who know, Supernova and ZeroHide are main house for design system documentations, and they provide very good MCP support. So allows you to fetch much more information for your design system or any documentation that you have at UI level than just rely purely on what you have on your code base. And one of my favorite ones actually is the Figma MCP. It's not mentioned for Figma, it's just because the way they designed the MCP is very clever, and it does make a lot of difference. So Figma MCP actually works in a way that it returns the tree of elements that you need to build your UI. It returns, if you have enterprise organization level, the code connect, which is just a method signature for your components on your code base, and returns a visual representation of your image, of your screen, which means that you don't have to screenshot. You can just paste the link on the chat, and the Figma MCP will automatically do all those kind of things for you. Why does actually matters? If you think if you think that design systems actually giving you the whole structure, the components that you need to run. What you're missing right now is context. Context is how the screen looks like, because if you just input an image, what we are doing right now is let the agent guess how things work. Even though we have like very good image processing at this point to trying to identify elements, you don't know actually if 8 padding pixels, like 8 padding, 16 padding, whatever, is the same one. The agent just guess it might be something. It might be 6, agent might put 4. The icon there, the agent is not going to understand. But all these informations you can actually get with Figma MCP, which means that you reduce the guesswork to real instructions at that point. The image is just a reference for validation for the final output. And you don't have to be stuck with just Figma MCP. Something that like we started doing, there's a lot of companies actually exploring this, like DCN, they have their own MCP to communicate with their components. So when you're trying to create a screen, it connects to an MCP and fetch all the information for the given components. So if you need variations, like how the UI is going to work, like I need a button. What are the variations that you have for this button? I need a pill. Give me all the pills. Give the documentation. Like all those kind of informations are already provided. So you can build your own MCPs instead of relying on other third-party tools and be much more directly with what you need, or just build your CLI as well. And one of the last ones is the agent rules, because right now we are giving AI structure of components. We are giving context, which much more rich information with the tree of elements and all the components that needs to be used. And now we come with the rules, which is really important, which is pretty much like do's and don'ts, helps the LLMs to understand what they should be doing and what they should not be doing. We have the fallback. So if something is not found in the code base or in the instructions, where should I look at? And design partners follow, which is really important, especially enterprise projects, because you get to a point where you need to follow standards. And if you want to have a completely autonomous agent that can actually produce UI, you need to follow those design partners, otherwise you get rejected on your PRs. So agent instructions can do much more than that, but that's basically what I use on my daily. And for instance, like those, always use design system tokens, which, let's say, like, if you're building dynamic UI or white-label case, you don't want hard-code informations. You want to use your design tokens because most of the times they're actually supported from Token Studio, Figma. You want to have that information on your tokens, and you want the AI to be able to fetch that information and properly use it. Never create components that does not exist in the design system. That's actually my golden rule. And that's why capital letter. There will be a lot of cases where you're working with screens and the component does not exist, and your agent needs to understand, like, what do I do here? Is this a reusable component? Should I create a component locally or not? The golden rule is like, don't create, because most of the times, these components might be not validated by a bigger group, and it just needed to be created locally because it's a very small component. Or there's a lot of cases where AI agents, they fall back in cases where they're trying to chunk the UI, and they believe that these chunks should be also components, when the reality is no, you're just doing that for better graph performance. And fallbacks, so if something is not found, where do I look for the information, right? You could look at the snapshot test. You could look at, if you have a demo app, you just point them to the demo app, or re-implementations. I usually point all mine to a snapshot test, because snapshot tests are quite useful, as you have to print every single stage. And partners, run one preview per feature. Like, that's something that I quite do. Like, don't have chunky previews. Always work with the smallest piece together so you can actually have faster. And faster previews. And if you're working with autonomous libraries that can actually generate snapshots from previews, that makes a huge difference. So this kind of like agent concept helps the agent to perform less wrong work, let's go. So far it's like, yes, you input all these informations, you make sure that agents have a structure, context, rules, put all these constraints, you're trying to mimicate how actually a UI engineering would work, but can you prove that works? I think that the first case of Figma is interesting, and I want to break down how it actually works. Figma Make does not create UI from scratch. That's something that not a lot of people actually understand. Figma Make is powered by Simple Design System, which is the open source design system solution. So when you prompt to Figma Make, what Figma Make does is it gets all the components that are needed. Figma Make does not need MCP because inside the Figma Canvas context has complete access to all the tools that MCP has. So it fetches the context, structure, tokens, connects to all the information that you have, get that information together, and put the screen that you need. So it's like, okay, but what about agent rules? There's a file there that's called a guidance, or guidelines, which is all the guidelines that Figma MCP actually works on top, like to make sure that it can build the UI. So at the end, this is not like something like crazy. Like we are in this golden rush that every single company is trying to build the most advanced system to build UI from scratch. And actually, they're just powered by the same foundation, which is basic elements, like design system, good context, information, and the last one, which is rules. You get all that information available everywhere. So this golden rush, in my opinion, doesn't exist. It's just a hype. And it's not just Figma that actually uses this technique. This technique is actually used across the industry. Lovable. How many people actually use Lovable? A lot. And it's exactly structure that Lovable does. Reloom, Builder.io, all of these companies are just using the same strategy to build. Of course, they have their own LLM training in-house to support the AI work, but without context, design system rules, the agent doesn't do anything. It's just, repeating myself, it's just guesswork. Like, they don't actually work as expected. So, what are the learnings that I had on this path trying to figure out this? Because we get asked every day, like, can you ship something fast? Can you ship UI? Can you prototype why this doesn't work? And putting all this together, it gave me some really good learnings, which is increasing the context actually performs better output, but also reduce the context window, so you might hit hallucination at some point. Constraints helps a lot to avoid guesswork and reduce the scope, keep things tight in. I'm always fan of design system, regardless of agent. Was working with design systems before that, but design system is always going to be the key for the success of like actually building UIs. Providing real examples of like do this, don't do that, actually helps the agent to understand what are the bad patterns and the good patterns to follow. For instance, we work with tokens everywhere at Bumble, and providing the agent the ability to understand how token system works and how to connect things, reduce the amount of like, on our prototypes, amount of like hard-coded information. And there's always a fallback that says, hey, if you don't find something in the design system, try to look here, or you can create exception only if those cases are actually present. And less thinking works a lot. So you provide the answers before the agent needs to ask those questions. So it's one prompt and go. What doesn't work and didn't work? Free-form prompts. Doesn't matter how good you are at prompting, unless you're working with Veil, you're not going to get a very good result. You're always suitable for like guesswork. Visual reference just by itself does not actually help as much. Like, it does help, but it's very, like it opens a room for interpretation that you don't want it to deal with. It's still guesswork at the end. It doesn't matter, because you input the information, and that information needs to be parsed, transformed into tokens, and tokens will be inputted on your agent. And the default behavior of the agents actually doesn't work as expected. Like, you can try to talk over this, trying to, question your agent about it, like why you're doing this, why you're doing that, but things just don't go as expected. It's like, instead of like the full behavior, feeding all the information actually work much better than expected. Yeah. So to wrap up, the agent efficiency stack. Design system, MCP, and agent rules. It's not a golden path. It's just 3 simple things. Majority of the companies right now are using this. So it's just putting all the pieces together and reducing the guesswork. And structure, context, and constraints equals to better output. I was asked to put the picture of my cat, baby. So give you a better context. But if we get back to your first sample, how actually that looks like? Can we actually have better outputs? I'm just like saying something like random, or actually it does work. So I got all the information that we had and got the Figma design. MCP working as expected. We had documentation in engine rules, and that's what I got. It's 99% close to what's supposed to be. Believe it or not, this screen is fully built on design system, which every single thing is tokenized. Every single spacing is actually the same spacing that you see in the image, and all the placeholders that you see that actually, they are my rules that say like, if you don't find an image because you got lost, use that placeholder. The badge that you see actually is gray. You cannot see on the screen, but it's gray. It just could not figure out what was the right configuration for the badge. And that's very important to explain, because Figma MCP does not give you Swift UI code. It gives you React and thing with CSS. So what happens is when you query your agent, it needs to interpret that code and transform that in Swift UI. Then use Code Connect to get the elements. And sometimes, because the context is too big, it might lose a little bit of information. So even though this screen is fully backed by the design system with all the information that it gives, there are a couple things that actually got missed. But it took me 30 seconds just to update 5 lines of code to actually have a representation that is almost one-to-one with our design. And this is built in SwiftUI in less than 5 minutes. And if we compare to Figma Make, I think that this is better than Figma Make at this point, because it's fully native, fully powered by the design system, and you can actually iterate over this screen like as a real engineer, and you will not have problems because you follow all the design patterns from your project. All the components are there. The images are 100% real, and in this case, everything is backed by the same information that your main project, and the AI agent just put the things together. And that's it.
So this might be too simple a question, but can you talk about the difference between a design language and a design system?
Yeah. So design language, it's much more broad because it gives like design system, it will give you all the components that you have. But design language is also the branding. So it's much more broad, that information that you get. So like, you need to define branding, you need to define logos, how things are going to work together, like the core elements, colors. That's the design language, right? The company uses these fonts. When you get to design system level, you already know the fonts that you're using, you know the colors. It's just the components, the structures, and the tokens to be shipped on your product. Design language defines the visual identity of the company.
You mentioned in passing design patterns, and that to me evokes that the design patterns we use in software came from the design patterns in architecture. They came from Christopher Alexander's design patterns. Are there things that you would suggest we bring back from design systems to programming also? I mean, we're solving some of the same problems with AI and code that you're solving with design systems and AI. Are there lessons that you would bring back from there?
So it's interesting.
You can tell me that's not a good question.
It's a hard question. So we technically keep going back in time and just bringing things back. And we started like a long time ago. We built UI libraries, which was the first concept that we defined, and every single project was backed by UI library. Then at some point we lost that information, and now we came up like a much more constrained topic, which is design system, which is not just for engineering, it achieves design or design level, and it goes for market everywhere. So it's tricky.
I really enjoyed this talk. Please thank Raul.
Thank you.